Brand. So I have over 11 years of experience in software development. I've been working with big data technologies for more than 4 years now. So I'm very passionate about big data and Hadoop technologies. Okay. So I'll be the instructor for this session. Okay. So let's get started. The session objectives, here is what is the agenda. So first I'll introduce you to the definition of big data, and then we'll briefly talk about what Hadoop is, and then we'll talk about the distributed file system, and then we'll get to the core, that is the MapReduce. So we'll try to understand the MapReduce with some examples. We'll solve a simple problem in the class, okay, and then we'll understand how the industry uses MapReduce to solve the big data problems. And we'll towards the end we'll share some interview questions on Hadoop, especially the MapReduce, and I'll open up the session for question and answer towards the end. Okay, so this is the agenda. Okay. So before even we get started, right, I would like to just quickly get your expectation. So what are you expecting from this session? Okay, so here is what here are some comments. So generally, the summary of the messages that I have got so far is, so some of you, for some of you, the expectation is like you are in different field, like you are in testing, or in you are in mainframes, right? Or you are a Java developer. Can you pursue your career in big data? That's one of the common question. And then the other question that is commonly asked is, can I pursue big data at this time? I mean, is it a right choice? So will the demand remain the same in the coming years? So these are the common questions that are asked. And again, last but not least, can I take up the course with Skillspeed? Okay, am I making the right choice? So I'll try my best to answer those questions, okay, in this class, friends. So let's get started. I mean, if you still have, I mean, in addition to this, what I just said, I mean, if you have any other expectation, please use the chat window and send over your expectation. Okay. All right. Now let's get. Now let's talk about big data and its challenges. The first thing we'd like to do is understand what is big data. Okay. So I would like to get your perception here. So when you hear the term big data, there's so much buzz about big data, right? In the industry, everybody talks about it, and many organizations think others are dealing with it, and there's a lot of demand for big data engineers. So what, according to you, is the meaning of big data? Okay. So here I get some answers. Some of you are referring to the size, right, to the volume. That's good. So it's not just the size and or the volume. Okay. So the big data is much more than just the size or the volume. Okay. So we'll try to formally define it. Big data refers to the data which is definitely which is too large. I mean, the volume of the data that you generate on a daily basis can vary from hundreds of gigabytes to hundreds of terabytes to hundreds of petabytes. Okay, and it's the data which where the data is generated too fast. Okay, it refers to the velocity. So some of the examples for the velocity includes the Twitter data. You know, like every per second, millions of tweets are sent. Now, you know, if you want to do some analytics and find out the top trending tweets, okay, then you need to ability to collect or manage the streaming data, the millions of tweets per second, to find out the top trending tweets. That is one example. Other examples include in the capital market domain, the tick data. So many of you know about level 1 data, level 2 data. I mean, if you are from a financial if you are from a financial domain, so you would be knowing about the level 1 data, level 2 data. So there in the tag data, basically the ticks and the codes data, the code, if you look at the volume in the equities world, the volume of the basically the velocity at which the data is generated, so it would be again around millions of quotes per second. Okay, so these are the examples for the velocity. Okay, and again, continuing the definition of big data, it is the data which exists in various form. Okay, it's the data which exists in various form. It can, like your structured data. Structured data is the data that you generally store in an RDBMS. The data which has a schema, the data which has a structure, the data which you can store it in a database, or even the big data can exist in unstructured data. Unstructured data, the quick example is the data that you upload to your Facebook. Okay, so what all you do? So you upload audios, we upload image files, and we write comments, okay, and so on. Okay, we upload videos, and also the other examples include the log files generated by your web servers, or it can be a sensor log. So these are all the examples for unstructured data. Okay, so if we can now summarize all this, so it is a data which is too large, right, which is generated too fast, and which exists in various forms, and finally, and it is a data which cannot be managed using standard tools and techniques. Okay, so you cannot really manage big data using your traditional RDBMS or traditional database management systems, DBMS. The reason is because because of its, one is the velocity itself, and also the variety. If you look at it, it also exists in various forms. And if you can, some of you can tell me why can't we use an MPP like a NetIS, Greenplum, and so on. So the MPPs are good at handling structured data, but they are not really good at handling unstructured data. So these are some reasons why you need a specialized system to manage big data. Okay. So here is the term. You can see the definition. Big data is a term for a collection of data sets so large and complex it becomes difficult to process using database management tools or traditional database processing applications. So systems generate huge amount of data from terabytes to even petabytes. So it's difficult to manage huge data even using any of these MPPs. Okay. Next question we'd like to understand is about big data. So who generates big data? Right? So much we heard, so much we hear. So but who is really generating? So is the data generated only by these companies, Google, Facebook, LinkedIn? These are some. Okay, so these are well-known examples that everybody is aware of. Google, we know they are the pioneers in the field of big data. They are the ones who released the white papers which inspired the development of Hadoop. So Google, so as we all know, they collect data from the internet, right? And they slice and dice the data and build indexes, and they have a powerful search platform. Okay. And Facebook we know about this. This is a social media website. Again, they every day on a daily basis they generate petabytes of data. So they have more than 1 billion users, almost like around 253 and 300 million users are the users will be active most of the times, and they generate a lot of data like the ones that we mentioned. The audio, they upload videos, they upload audios, they share comments, okay, and they do likes, so many things. And LinkedIn is another application, so where again the number of users are in hundreds of millions. Okay, so here also they generate several terabytes of data. So these are some examples. Again, you should not be under the assumption that these are the only companies which generate big data. Okay, many organizations do generate big data. This understanding is very much important. Otherwise, your thought process will be limited. Okay. So some of the organizations, let me give some examples. Many of you must have heard about this clickstream analytics. So what is a clickstream? Okay, clickstream doesn't mean that it is not just limited to the clicks that you do on a website. Okay, any activity Okay, so click stream basically refers to the stream of events collected by the applications. Okay, stream of events. So what are these stream of events? Stream of events are the activities, done by the users. Some examples include like some of you play games on your smartphones. Okay, now smartphone penetration is lot when compared to a decade back. Now almost you can say in United States at least 40% of the population has a smartphone. In India at least 20% of the population has smartphone. So number of users who are using smartphone are definitely more. Now on your smartphone you have a lot of different type of apps. Okay, so different type of apps. So when you use those apps, when you use those apps, for example, let's say you use some games. Okay, so you're playing some games. So when you watch the tutorial or when you complete some level or when you do some purchases, every event is recorded and sent back to the server. Okay, your app basically collects the data, collects the clicks that you do, and that data is sent back to the server. And the studio, what they do analytics on the data collected from millions of such devices and find out, are users liking the tutorial, are they completing the tutorial, and what kind of in-app purchases are they doing. Like what kind of characters are they purchasing while playing the game? How many users are active today? How long the users are playing our game? How many times they are opening our game? So these are some of the analytics that they do. Okay, that is in the gaming world. Now coming to another example of e-commerce application, where when you go to a e-commerce application like an Amazon, Flipkart, and so on. So what do? You look for products. Okay. When you look for products, suppose if you look for a cell phone today, right, and you come back tomorrow, and you would be surprised to see that they will recommend a cell phone. How are they able to do that? Okay, how are they able to do that? Because any activity that you do, whether you purchase or not, on a website, it will be recorded, and they will find out, okay, which product the users are interested in, and if there is some product which is some category of products which is viewed by users a lot, then those products are they customize the website and they show those products, okay, on the landing page. Okay, so these are some examples of the big data applications. Okay. So before even we get started before we even get started with big data and Hadoop, so these concepts should be clear. The first you should answer yourself, is big data generated? You should be convinced that yes. And will it remain so in the coming 5 years? You should be convinced, yes. And is there demand in the market? Yes, it is demand because data is continuously growing. So they need specialists to deal with their data. And as I mentioned, when you look at the definition, it is too complex. It cannot be really dealt with some simple RDBMS. Okay, so they need engineers, so obviously the demand will be there. Okay. Now, having understood all that, like what is big data, who is generating it, how the companies are using big data, now let's talk about which system do they use. Okay. So do they use some expensive hardware? Do they use some supercomputer, or really do they use some commodity hardware to manage the data? Okay. So as I said, since it has many characteristics, so they cannot limit to some MPPs. So the default system at the moment used by many organizations is Hadoop. So Hadoop can be used easily for processing huge volume of data and also for managing huge volume of data. Okay. So how? So let's quickly understand here. Okay. So your Hadoop. Okay. So your Hadoop, if you want to define it in layman's language, so it is a system. It's a framework for distributed data storage and distributed data processing. So I said distributed. Okay, I said distributed. That means it's not a standalone system. It's a distributed system. So obviously, the moment your volume of data increases, when you need scalability, when you need more storage, more processing power, so you build a distributed systems. Okay, just a second. Okay, I'm back. So it is a distributed system. So your Hadoop follows the master slave architecture. So they will have a master node and they have a set of slave nodes. So let's quickly look at the architecture and understand how it actually stores data and manages data. So they have a master node, follows master slave architecture. We have a master and we have a set of slaves. So these master, so it has two components. As I said, one is a processing component. So your Hadoop has two components. One is a processing component, other one is a storage component. So each of them follow the master slave architecture. Okay. So first let's look at the storage. Storage, the master is called as name node and the slaves are called as data nodes. So what happens in the storage? So suppose this is your file. So whenever you store the file into the HDFS, the storage component is called as HDFS. HDFS is Hadoop distributed file system. So what happens is, so your file is split into blocks. Okay, assume this file is 128 MB. So in Hadoop 1.0, the default block size is 64 MB. So your file will be split into blocks. So let's say these are my blocks, A and B are my blocks. Okay. So these blocks, when they are stored in the cluster, they are not just stored on one node. So your blocks will be distributed across the nodes. So your block number A will be stored here, okay, and your block number B will be stored here. So that means whenever you store the data, your data is split into blocks and stored across the cluster. And and whenever it is processed, let's say this data you want to analyze and get some insights, and you want to use Hadoop for that. So what Hadoop? So Hadoop has a processing component. Hadoop also provides you a processing engine for that. So what we looked at was a storage engine. So in the processing engine, the master is called as the job tracker in Hadoop 1.0. Okay, in the latest Hadoop 2.0, we call it as a resource manager. Okay. So in the processing, it has a master. In Hadoop 1.0, it was called as a job tracker, and you have a slave process which are called as task trackers. So these task trackers will be running on all of the slave machines. Okay. So what happens whenever you want to process? So the data is processed parallelly. So you have your A block will be processed on this machine, and your B block will be processed in machine. So what is happening here? So when the data is processed parallelly using a parallel programming model called as MapReduce. So this is just the basics of the Hadoop architecture, okay, the cluster architecture, and how the data is stored and how data is processed. Now let's look at the characteristics. Okay, so what is Hadoop? It's a framework that allows distributed processing of large data sets across a cluster of commodity hardware using simple programming model. So this is important, this word, commodity hardware. So what is commodity hardware? So here, when we talked about the slave processes, so your slave processes run on the slave machines. So these slave machines are basically, we don't use enterprise class hardware, because Hadoop, the USP or the main idea or goal was to make it work on commodity hardware. So what is commodity hardware? Commodity hardware is the hardware that you can buy from multiple vendors, and also it's a hardware which is inexpensive. Okay. Again, do not think that commodity hardware is a machine having the lowest configuration. No, that is not the definition of commodity hardware. Commodity hardware means it is inexpensive, and you can find many vendors in the market for that kind of hardware. Okay, an example can be a machine having 8 CPU and 32 gig RAM. Okay, so that can be a commodity hardware. Now moving on, so it is an open source data management technology with a scale out storage and distributed processing. So we understand the distributed processing. So let's talk about scale out storage. So when you want, what is scalability? Scalability means how do I increase my capacity? So here, what kind of capacity we need? Here, okay. So here, the capacity is increased horizontally. What is the meaning of that? Like if you want more storage power, your volume of data doubled. Now you need more storage in your cluster, or you want to increase your processing capacity. Okay, you want to process the data parallelly. Then what you do, you generally in a traditional system, what you do in your database, suppose your queries are not performing well, what we generally do, if your database is too slow, right, you basically increase the configuration of the hardware. Okay, basically you replace your machine with a higher configuration machine. This is called as a vertical scalability. This is what we do in a traditional system when we need more processing for our storage. So whereas in Hadoop, so it relies on horizontal, meaning if you need more storage, all you need to do is just add few more nodes to your cluster. Okay, if you need more storage or processing, so you need just add few more nodes to the cluster. So generally, the horizontal scalability is inexpensive when compared to vertical scalability, because as you keep buying higher configuration hardware, the cost will increase. Okay. Now these are the characteristics. One is it is economical, so we spoke about it because it uses commodity hardware. It is scalable. Okay. It scales because it relies on horizontal scalability. It is reliable because whenever your data is stored in the cluster, so we saw this file getting split into blocks A and B and stored across two nodes. Suppose even if this node goes down, so your block number A will be available on another node in the cluster because of the replication supported by the Hadoop. So Hadoop supports default replication of 3. That means whenever you store a copy of data, 3 copies will be maintained in HDFS. So that way, even if your node goes down, your data is not lost. And then it is highly flexible because it allows us to query using different tools, process data using different tools. This is very important. So if you are a Java guy, so you can develop MapReduce program using Java. Like if you are a SQL, if you are a BI person, if you are a data architect, a BI architect, then you can use SQL. Okay, it is called a high query language. It's a dialect of SQL for analyzing the data. Like if you are if you are from a scripting background, if you know Perl, Python, and you are pretty familiar with some data flow languages, then you can use a language called Pig-Latin. Okay, so Pig-Latin is a scripting language using which you can analyze the data in HDFS. So these are different ways in which you can do the analysis. Okay, so let's move on. So what is Hadoop? How does Hadoop solve the big data challenges? So it's a platform designed to address the big data problems. And the reason is it can handle any type of data, right? Size doesn't matter. So it can handle any volume of data and also the variety, okay, whether it is structured, unstructured, whether it's audio file, video file, log file, or your CRM data. Okay, so it can handle any type of data. It can store and it can allow you to process any type of data. Now let's quickly talk about the Hadoop ecosystem. Okay, let's quickly talk about the Hadoop ecosystem. So if you look at the Hadoop ecosystem, it consists of some core components, which is the first 2 core components we spoke was. One is the storage, the other one was the processing. So later, as Hadoop evolved, became more stable, a lot of sub-projects added to the Hadoop ecosystem, so which were basically meant to make life easy for developer. So in this slide, we'll learn about those sub-projects and those other components which are added to Hadoop ecosystem. So we'll just group them into different categories and understand them. To start with, the first ones. What is the core component we studied? One was the storage. So storage component of Hadoop is called as HDFS, Hadoop Distributed File System, which allows us to store gigabytes, terabytes, or petabytes of data on a cluster of commodity hardware. So this is your HDFS, which is a file system which lies beneath your Hadoop. And then coming to the processing layer. Okay, when it comes to the processing layer, so what do we have in the processing? If you look at it, so there is a yarn. So we are looking at Hadoop 2.0 architecture. So there is this yarn. So what is this yarn? So yarn stands for yet another resource negotiator. So some of you are familiar with the term resource negotiator. So there are many resource negotiators. Some example include a Mesos. So what these resource negotiators do? They manage the resources, your cluster resources here. So yarn manages the cluster resources. So when I say what is resource, okay, we should be very clear with the definition of a resource. So in a computers, right, in the computer science, like even in computers, the machine, the resource refers to the CPU and the RAM and the disk space and the network bandwidth. So these are all the different resources that you need. Okay, if you want to execute any program, so your program basically needs these resources, okay, for its execution. So what yarn does, basically, it only facilitates, it provides resources for the distributed applications to run their application. Okay, so this is the component that was introduced in yarn. So which is introduced in Hadoop 2.0. So whose responsibility is to manage the resources and provision resources. So these resources are used by different applications. MapReduce is one such application. Spark, Shark, Storm, Samza, Tez. These are the other distributed applications that we can run on top of Hadoop 2.0 using Yarn. Now let's talk about the core of Hadoop, which is used for processing data, is MapReduce. So what is MapReduce? MapReduce is a powerful parallel processing model which is used to process data on the cluster of commodity hardware, to process data parallelly on cluster of commodity hardware. So if you use a MapReduce framework, then you would be developing jobs using Java language. Okay, please note this point. So there are different ways in which you can you can develop MapReduce programs to analyze data. One is Java. The other ways in which you can analyze data is using some scripting languages. If you know Perl, you can develop Perl. You can develop MapReduce program in Perl. If you know Python, you can develop MapReduce programs in Python, and so on. Any scripting languages as well. Okay. Now, what if I know SQL, or if I do not know Java, then you can use some the high-level languages built for Java MapReduce. So that is one other tool that is available for data analysis is Hive. So Hive provides HQL, which is a direct of SQL. If you're from SQL background, you want to use Hadoop, then mostly you'll be using Hive. So what Hive allows? So Hive is an abstraction built on top of Hadoop, so it allows you to create tables and write queries and analyze data. Hive acts as a data warehouse. Now then another next tool that is available for data analysis is Pig. So Pig, it provides a scripting language called Pig-Latin. So you can use Pig-Latin to analyze the data in HDFS, analyze the data in Hadoop. So Pig, the difference between a Pig and a Hive is a data warehouse, whereas a Pig is a data flow system. Hive provides a query language called as a high query language, which is a declarative language. The Pig provides a language called as Pig-Latin, which is a data flow language. And so that was about your processing component. Now moving on, if you look at other components, so we have a workflow manager. Okay. So what is this workflow manager? So some of you must have used these workflow managers. I mean, if you have deployed some applications in production environment. Okay. Generally, if you are from a data warehousing background, okay, if you have done some, if you are part of some ETL, so you would be doing all this. So what is the workflow? Workflow is basically consists of a bunch of jobs, okay, with their order defined, with their sequence defined, with the dependency defined. So what is the meaning? So if I have some jobs like A, B, C in a workflow manager, you can define the dependency, saying, okay, run the job B only after the completion of A, and run job C only after the completion of C, and so on. So this kind of workflow management and also the scheduling of these workflows you can do using a workflow manager like Oozie. Okay. Now moving on, so that is your workflow manager. Okay, this is one category. This is one sub-project that is in the Hadoop ecosystem. And then look at the other components. So there is a NoSQL store called HBase. Okay, your Hadoop is mostly used for batch processing. Now, if you are looking for some NoSQL data store to write records, okay, if you are looking for a throughput of 1,000,000 writes per second or 1,000,000 reads per second, then HBase is a NoSQL store you can use it for. So HBase is a column-oriented key value store. It's a non-relational database. So your HBase is built on top of HDFS. If you're looking to build some real-time application, you can think about using HBase. And then the next category is the fifth. So that is the tools used for importing and exporting data. So what is that? That means if you have data outside the Hadoop ecosystem and you want to import the data. Like one scenario is you have data in RDBMS, like Oracle, Postgres, DB2 and so on, and you want to import the data into your Hadoop ecosystem. Then you can use this tool called Scoop. Scoop stands for SQL for Hadoop. So you can use this tool to import the data from RDBMS into Hadoop, and also you can use it to export the data from export the data from Hadoop into RDBMS. So this is a tool that's used for that. Then another scenario wherein you will be ingesting data is like connecting to your Facebook server or a Twitter server. Now you want to connect to this Facebook or Twitter server, and you want to stream the data into Hadoop. Okay. Now this is the requirement. Then what you do, you can use an agent like Flume. So Flume is a tool used for this purpose, for collecting the streaming events and ingesting those events into Hadoop. So it's not only for just a streaming event. Like suppose if you have some web servers, so which continuously create web logs, or any servers where the continuously log files are created. If you want to ingest these log files into HDFS, now into your Hadoop, then you can use Flume. So Flume is an agent used for streaming data collection or log files collection. So it can deal with both structured and unstructured data. So this slide is very important in this discussion, because if you're looking for joining the course, learning about Hadoop, and you want to learn about different components, so industry experts expects you to know all these things. Okay, this and an ecosystem is continuously evolving, and these are the basic things that are being used by the companies to manage big data, starting from data collection to building pipelines to building data warehouses, right, and for analysis. So you need to be familiar of each of these tools, and so these components are covered in our 10 modules course. So our regular course, we talk about all these components in detail, and you will get a hands-on experience on all these components. Now moving on to an important topic. Okay, let's talk about MapReduce. So what is MapReduce? So let's try to understand here. So MapReduce, in layman terms, it's a programming model used to process data parallelly. Okay. So what is that? So what are the different things involved here? Let's understand the internals. Okay. So let's take a scenario, simple scenario, to understand the importance of MapReduce. Friends, I'm receiving your questions. So what I would like to do is, as I said in the beginning, I'll open up the forum for question and answers towards the end. So first, let me complete the agenda. Right, let me go over the things that I have planned, and towards the end, you will be given opportunity to ask questions. Okay, I'm reading your questions. I'm just parking them. Okay. Coming here to the MapReduce, some real-time scenario why it is useful. Let's say you have a job. Okay, you have a job, and there are X tasks in that job, and you take 100 hours to complete just by one person. Let's say one person is doing it. How much time it is taken? Like 100 hours. So obviously, so what is happening here? If you have X tasks, the tasks are handled sequentially, one by one, and the time taken is 100 hours. Now think about it. If this gentleman had some workers, okay, so he had some workers, what he could have done, he could have distributed those X tasks among the 10 resources, okay, among the 10 resources. Now what is happening? So these 10 resources, they work on those X tasks, right? So the parallelly. Now what is happening? Your tasks are handled parallelly, so the amount of time taken has reduced from 100 hours to 10 hours. So this is the advantage of dividing your job into tasks and running them parallelly. Okay, so it will reduce the execution time. So when it comes to the machine, similarly, so let's say you have a job which is done by single machine in 100 hours. Okay, if the same job, if you can split the job into tasks and assign those tasks to individual machines, and if you run them parallelly, you can see here that amount of time taken is 1/10. So that means if there is a job that you can split and you can run in parallel, then if you use a distributed programming model like parallel processing model like MapReduce, so you can you can process the data sooner than the time taken by processing it sequentially. In the present world, when we are dealing with terabytes of data, petabytes of data, we cannot rely on sequential processing. Okay, obviously we cannot. Now let's take some examples. One is there are some scenarios where MapReduce is used to get the insight, like in the stock market, in the financial world, in the capital market. Like if you want to find out the maximum stock market levels recorded in the span of 5 years. Okay, in the last 5 years, if you want to find out the maximum stock market level, then you have to go through the billions of records. Okay, and then if you want to go through billions of records, so best thing is you store it in a Hadoop, where when you store, your data is split into blocks, and then you develop a job, and those job, when you develop the job and when you submit to the cluster, so it will basically split. It will create tasks for the data that is stored across different nodes in the cluster, and those tasks will be executed parallelly, and you will get the required answer. Okay, in a shorter time, in a lesser time. Okay, there is another problem called in the healthcare domain. Okay, like de-identifying the personal information, personal sensitive information. So what generally happens? Let me show you here. So what generally happens? Like let's say this is your this is the medical history of some patient. Okay. Let's say they have this information like our name, age, our cell number, and diseases, some medical condition. It so happens in the pharmaceutical world, in the healthcare world, so these data is shared with third parties. So what do they do? These pharmaceutical companies collect this data from different sources like laboratories, hospitals, like pharmacies, and they do analytics and find out the diseases, the prevalent diseases. Based on that, they make investment. But the concern is, can they share some personal information like this? Can the hospitals share the sensitive information like this? So what do you say? Should they be sharing the sensitive information, like your email address, password? Let's say in US, if it is SSN number, it's not allowed. It's illegal. Okay, it's completely not allowed to share the sensitive information. So what do they do for that? So when you have some billions of records like this, okay, when you have billions of records, when you want to share it, so they do the de-identification. Okay, so they do the de-identification means they'll mask all the sensitive information. Like phone number is a sensitive information, they just mask it. Like SSN is a sensitive information, they just mask it. So these are some examples. There are many more examples. Now let's talk about the traditional solution. Like if you were to solve this problem, the problem that I just defined. Okay, here. Let's say you have a medical history of the patients, and you have like billions of records, and the volume is around, let's say, a terabyte. Now, if you are asked to do a simple exercise like de-identify the cell number, so how are you going to do it? Okay, first question I would like to ask is, will you do it parallelly or sequentially? I said you have 1 terabyte, and you have billions of records which you need to process to de-identify the sensitive fields. 500 gig or 1 terabyte, let's say size. So how are you going to do it? Will you do it parallelly or sequentially? So obviously we will go for parallel processing, right? That's a logical thinking. Now when you do it, so what are you going to do? I mean, if you want to do it without using Hadoop, first you would split your data sets. Okay, like you'll create a 50 GB splits and copy each of them to a different machine, and then run the program that you write. Like it can be a generally, if you are not using Hadoop framework, what you will do, you will write some Python program, Perl program, C, Java, any program to basically read this record in that split and replace the phone number or a sensitive field with a masked value. And then after this, when it is done, you have the intermediate data ready. When you have the intermediate data ready, what you do, your problem is not solved yet, right? Because your data is residing on 10 different machines. So what you need to do, you need to collect that intermediate data and you need to aggregate it. You need to merge them. So that's what the next step you do. You collect the intermediate output, and then finally you do the aggregation. You merge them and you give the output data. Now if you look at the different stages, okay, traditionally if you do it, if you try to solve it parallelly, there is a lot of complexities involved. First, you are involved in some housekeeping activities. okay, which is not really, which is not related, which does not deal with any business logic. Okay. And these are, these are the tasks that are repeated for different type of big data problems. What are those? Like splitting your data, then copying to individual machine, and then running your program, and then collecting the intermediate data, copying to another machine, and then running some aggregation program. And in this, so the splitting the data and collecting the intermediate output, so these are something, manual that are repeated. That is, these are common things that are repeated across various problems. So what do you look for? You look for some framework to take care of this. Okay, you want to just focus on the business logic. Okay, so that is exactly what Hadoop offers for you. So Hadoop will take care of the regular housekeeping stuff, and it will let you process on writing only the program. Okay, for the two different phases. One was the map phase. Okay, this we call it as a map phase, where you split your data into blah, right? Your data is split, split, and you run your program on each split. So the first stage of we call it as a map phase. Okay, so basically you will be developing just a mapper program for the map phase, and in the aggregation. So when the aggregation is done, when on the intermediate data, the aggregation program that you run, so that we call it as a reducer. And this is called, the aggregation stage is called as a reduce stage. So you can see here, now you have input data. There is a framework which comes to our rescue, which takes care of splitting the data and running our mapper program and collecting the intermediate data and sending it to reducer, and then in the reducer running our reducer program. Okay. Now, so having looked at that, so let's quickly do a simple analysis. Okay, let's look at a very simple use case and understand how we can use the MapReduce programming model. So for that, I have a use case. Okay. So this is an interesting use case. Okay. So the use case is, first let me show you the data. So I have some input data here, Cloudera webinar input data. So this UI is a name node UI. The UI that you are seeing is a name node UI. Name node means we spoke about it earlier. This is the master process of your HDFS. So let's look at the data first. User Cloudera webinar input. User Cloudera webinar. Okay, input data. So what I have basically the pricing data. Some of you from the capital market world, you would be knowing it. So every day at the end of the trading, there will be summary data generated. Okay, that is called as EOD pricing data. So this is the pricing data. So what we have for a particular stock, so we have the EOD pricing data for the last 5 years. Let's say this is the date, and this was the opening price, and this was the highest price of that stock on that particular day, and this was the closing price, and so on. Okay, so this is the pricing data that we have for the last, let's say we have this for the last 5 years. Now you want to buy the stock and you want to do some analysis. So what kind of analysis you want to do before you buy this stock? Let's say you are a trader, you are recommending this stock for some so one of your customer. Now you want to do some analysis. Let's look at the analysis. So you want to compute the frequency of the stock market changes for that particular stock. Okay. For example, you can say for a given stock, let's find out how often in the past several years the stock price has changed by 1%, 2%, or 3%. Let's say it so happens sometimes the in the Satyam case and in many cases when the fraud when the fraud was known, what happened? The prices tumbled. So all of a sudden within a day, the prices was reduced to half, by 50%. So is there any volatility if you want to find out? Is the prices varying too much during the day? So if you want to find that out, so let's see how we can do it. So let's see how we can do it. So here what are we doing? So we will use Hadoop for that because we are dealing with let's say last 5 years of data, and if you want to do it for the last 20 years of data, you can still do it. So for that, I have written a program. So let me show you the program here. So this is our program. This is the program that I have written. So here we are analyzing our data using MapReduce framework. Okay, so when we use the MapReduce framework, we need to develop our jobs, MapReduce programs using Java. Okay, we are not using Hive or Pig here. So here we are using the MapReduce for analyzing our data to get the insight we just spoke about. Okay, so what have I written? I've written a job here. So what this job consists of? This job consists of three classes. One is a driver. So whenever you develop a MapReduce job, you need to have these. One is a driver, other one is a mapper class. This is called in the first stage. Okay, and there is a reducer class. This is called in the aggregation stage. Okay, and this is my driver stock analyzer. So your driver, this is the main method of our driver. So in this here we have all the job configurations. Like you can see, I have configured I'm registering my driver, setting my job name, okay, and setting my output key, output value, and I'm registering my mapper class, reducer class, okay, and I'm setting my input format, setting my output format, and so on. So basically this we have used the Hadoop APIs, configuration, job, file input format. So these are all the APIs provided by the Hadoop. And Hadoop also provides a lot of other APIs using which we develop MapReduce programs. Now let's look at our mapper. So what are we doing in our mapper? So this is our mapper class which extends the mapper API provided by Hadoop. So these libraries you can find it in this package, org Apache Hadoop MapReduce. Okay, this is a package which contains the APIs that we have used in our program. So this mapper. So this mapper, so what it has, it extends the mapper class. So these are the keys. Basically, your the types of input key type and input value type, output key type and output value type. Your MapReduce model deals with keys and values. Okay, your model deals with keys and values. When we saw the two stages, first was the map stage and other was the reduce stage. In the map stage, what the framework does. First is your data will be from the data splits will be created. So from the splits, each record is read and record is passed as a key value pair. Okay, record is passed as a key value pair to your map pair, to your map function. So here you can see that this is the map function which takes key and value. These key and values are generated from each record in your split. Okay, and this is the context which collects the mapper output. So what are we doing here? Let's say this is the one record that we read. Okay, this will be there in the value. We are creating an array of tokens, and from the token, what are we extracting? We are extracting the highest price on that particular day, and also we are taking the open price. We are taking the open price. This is open. And we are taking the closing price, and we are finding the change. Okay, what percentage did it vary? Like if it opened at $100 and it closed at $50, that means there is 100% change. Okay, sorry, there is a 50% change, not 100%. And if it opens at $100 and if it closes at $200, then it is a 100%. Now what is that? We are basically finding that percentages, and in the last 5 years we are saying how many times the price has changed in different percentages. So we are emitting the change and the percent, and this is the change percentage and this is the numerical one. So what we do in our reducer, this is our reducer which extends the reducer API provided by Hadoop. This is the input key type, input value type, output key and output value type. And this is the reduce function which takes key and list of values and context as input. And for each value in the list, what are we doing? We are counting the occurrence. We are summing up. So when we sum up what we get in our reducer is for that particular percentage. Let's say the percentage is 50. So we will, when we count all the ones, we'll know how many times the price varied by 50 percentage. Okay, in the last 5 years. So this is our MapReduce program. Okay. So the details of this, okay, the different stages in which the different stages in which your execution happens, all this are explained in detail in the regular course. Okay, let me show you the execution here. So first thing, you need to load the data into HDFS. So these are the commands that we use to load the data into HDFS. HDFS put stock data into this HDFS location, and then when you want to run your program, this is the command that we use. Hadoop jar. This is the jar file which contains your mapper, reducer, and driver, and this is your driver class, and this is your input location, and this is your output location. So these two locations should be HDFS locations. Okay. Now let's run this job. So what is happening, you can see when the job started, a job ID is created, and we can see the progress. This is the progress of the job. Like when you are dealing with terabytes of data, it will show you 10%, 20%, 30%. After the completion of map phase, the reduce phase starts. Okay, and when the execution is complete, these counters are printed. So these counters, you can see some are related to the job counters, like how many tasks were launched for that, how many reduced tasks, how many map slots, and then there will be file system counters, like the amount of data read. Okay, and this is the framework numbers, like number of records passed from each stage, from the split stage to the map stage, from map stage to the shuffle stage, from shuffle to the reduce. So all those numbers you can see here. Now let's look at the output. That's what we are interested in. Like, can I invest in that stock? Is the price too volatile? Now let's check it here. Webinar output 4S. Okay, user Cloudera. Webinar output 4S. Okay, you can see that. So the price was varied by minus 0.02 by 19 times, and if you scroll down and see, you can see that it varied by 0.64%, 36 times, and so on. Okay, so this basically it gives an insight how the price was varying, how many times. So you can see that sometimes it varied by decreased by 3.45% twice. Okay, so what you can do as an improvement to this program, so you can find out like the top 5 changes. Okay, the top 5 changes. This is something that you can improvise. So this is a sample use case. Now what is the advantage? The advantage is of using MapReduce is your data is processed parallelly. When you have large data, your data splits are created and those splits are processed parallelly. And also the next thing is your data, your code is taken to the node where the data is stored. Okay, unlike in your regular traditional ETL applications where you extract the data from the source and they take it to a node where the data is processed. So in Hadoop, your code is copied to the node where the data exists. Okay. So this is the flow. Like you have input data. From the input data, splits are created, and those splits are assigned to the tasks. Okay, and you can see the map task they execute in parallel, generates the intermediate data, and that intermediate data is copied with the framework to the reducer where it does the aggregation, and finally the output is returned into HDFS. Okay, so these are the different stages. Now what are the interview questions? You can see these are some of the interview questions which are covered in detail in our regular course. What is MapReduce? How an Hadoop application looks like on the basic components. So what is a name node? What are combiners? What are partitioners? what are the performance optimizations you can do when you develop the MapReduce job, what are the parameters that you can tweak, okay, and what if one of the tasks is running slow. So these are some questions that you can expect in the interview. What is the distributed cache? How do you perform joins in MapReduce? Okay, and many more. Job trends. Yes, the market is good. As you can see, there has been a demand, and you all know, you have done the homework. Currently, if you look at the average salary, in the Hadoop job, big data jobs get 20% more than the average salary. Okay. Now it's the questions time. So I'll take up some questions here. Okay, please send your questions, friends. Now, can we use Scoop for any RDBMS which uses ODBC or JDBC? Yes, any database applications, any RDBMS we can use it. Ask him. Zian says, is it possible to share the PDF? Yes, it will be shared. Okay. What is the use of Hive? Hive is a data warehouse mark. Like if you do not know, if you are not from Java background, if you want to analyze data using SQL, then you can use Hive. Hive provides a dialect of SQL for high query language for your analysis. Okay. There are some more questions. Let me take them. Reshma says, what's your thought on Spark versus Storm versus Hadoop? Spark is used for in memory. Spark does the computation in memory, Reshma. It's relatively faster, but Hadoop is more mature and more stable. Whereas Storm, okay, Storm is for event processing, okay, and Hadoop is Storm doesn't have any storage on its own. Okay, whereas Hadoop is it's a framework for storage as well as processing. How it is to ensure the data is evenly distributed between the nodes, so that master will take care of him. Okay, your HDFS takes care of that, balancing of the cluster and the distribution of data across the data nodes. So MapReduce is for distributed file system data analysis or to store the required data from raw data in HDFS. So MapReduce is not for the storage, Mohan. Storage is handled by the HDFS. Your MapReduce is for analytics. Okay. Okay. Ashwin says, in my current project, we are using Ab Initio for ETL Teradata as database. If you want to go to Hadoop, then how we can do? We can use HDFS to store the data, but how can we do the transformation? Okay, there is a pig. So our same pig is essentially used to build the data pipeline. Like all the transformations, that is the difference between Hive and pig. So pig is a right tool for doing the ETL. Can we use Hadoop along with the BI tools? Yes, there are a lot of other connectors built for Hadoop now. Now, like for example, your Tableau has connectors for Hive, okay, and even Informatica, Talent, and many BI tools have connectors for Hadoop. Okay. Now, friends, if you have any questions, any technical queries, we request you to reach us via our email. So this is our email. sales@skillspeed.com. Now I'll request my colleague Mohit to take questions and answer your questions related to the course. Okay. Sorry about that, friends. My colleague is facing some technical issues. Okay, sorry. Can you all hear me well now, friends? Yes, we do provide a course completion certificate, friends. After you complete the course. Okay. So this is the course content which I just mentioned. That is a 5-week course. The classes are held in the weekend. And after you complete the course, you will be provided with a course completion certificate. Okay. For any kind of technical queries, what I request is, we request you to send us an email. Okay. Thank you very much. Please do drop us an email. We will call you and we'll talk to you about any other queries that you have. Okay. Please leave your feedback. Thank you very much for joining today's session, friends. Okay, I'm just sending the email ID again. So thank you very much for joining today's session. So please leave your feedback. There is a survey form that will pop up.